They said it couldn't be done. Engineers looked at this canyon and saw only impossibility. A 565-meter drop to the river below, walls so steep that traditional construction equipment couldn't even reach the site, and weather so unpredictable that workers had only a few months each year to make any meaningful progress. Every senior engineer who surveyed the location came back with the same conclusion. This was suicide for any bridge. But China doesn't accept impossible. And what they built here is now the highest bridge on Earth. This is the Beipanjiang Bridge, also known as the Dug Bridge. And the story of how they literally split a mountain in half to build it will forever change how you think about the limits of engineering. Welcome to Project Scale. The province of Guizhou in southwestern China carries a nickname that tells you everything you need to know about this place: the land of 8 mountains and 1 water. For every unit of flat land, there are 8 units of mountains. The terrain is so rugged, so vertical, so punishing that some villages remained completely isolated well into the 21st century. No roads in, no roads out, just steep cliffs and deep valleys that swallowed any attempt at modern infrastructure. The Beipan River carved one of the deepest canyons in the entire region over millions of years. For centuries, crossing this gorge meant a dangerous descent into the valley, often along paths barely wide enough for a single person, followed by a treacherous river crossing and then an exhausting climb back up the other side. A journey that could consume an entire day just to cover a distance of a few kilometers in a straight line. Imagine living in a village on one side of this canyon. Your nearest hospital is on the other side. A family member has a medical emergency. What took ancient travelers an entire day now needs to happen in minutes. This wasn't just an engineering problem, this was a human problem. In the early 2000s, China launched one of the most ambitious infrastructure programs in human history to connect every province with a modern highway network. But Guizhou presented challenges that made other difficult terrain look simple. You couldn't just build roads around the mountains. There were too many of them. The entire province was mountains. The only solution was to go through them and over them. But what they were about to attempt had never been done at this scale. The proposed route for the Hangzhou to Ruli Expressway needed to cross the Beipan River Canyon at one of its deepest points. Engineers surveyed the site and realized they weren't just building a bridge. They were attempting to construct the highest bridge ever built in human history. At 565 meters above the river, the Beipanjiang Bridge would be taller than the Empire State Building, taller than the Shanghai Tower, taller than the Eiffel Tower, taller than any bridge that had ever existed. If you stacked 2 pyramids of Giza on top of each other, they still wouldn't reach from the river to where this bridge deck would sit. But height wasn't even the primary challenge. The canyon walls were nearly vertical, rising at angles that made conventional construction approaches completely worthless. There was nowhere to put scaffolding or support structures. Equipment couldn't be driven to the construction site because there were no roads. That's what they were trying to build. The roads that would eventually carry vehicles to this bridge didn't exist yet. Workers would need to create access routes just to begin the project. The engineers had to abandon everything they knew about bridge construction and think completely differently. Instead of building from the bottom up, the traditional approach for centuries, they would build from the top down, and they would use the mountains themselves as their foundation, turning the very obstacle into their solution. The design called for a cable-stayed bridge with 2 massive towers, one on each side of the canyon. But before a single piece of steel could be placed, they had to create something that didn't exist: flat surfaces on the mountain sides to build those towers. This meant removing millions of cubic meters of rock from 2 separate mountains. They were going to cut the mountains in half. Controlled explosions echoed through the canyon for months on end. Skilled demolition teams drilled blast holes into the rock face at precise intervals, carefully calculating each explosive charge to remove exactly the right amount of material without destabilizing the remaining mountain structure. One miscalculation could trigger a landslide that would bury the construction site and kill workers below. Every blast was a calculated gamble. The excavation teams worked in conditions that would terrify most construction workers. Suspended on ropes against vertical rock faces, drilling into stone that could give way at any moment, they carved away at the mountain day after day. Some workers later recalled that they could feel the mountain vibrating through their equipment, as if the rock itself was fighting back against what they were doing to it. The excavation alone took over 2 years. When it was finished, 2 massive platforms had been carved into the mountainsides, flat surfaces large enough to support construction cranes and tower foundations, all sitting 565 meters above the river below. From the air, the mountains looked like giants who had taken bites out of their own shoulders. Now came an even bigger challenge. How do you actually build a bridge when you can't reach the middle? Traditional bridge construction often relies on temporary support structures called falsework. These scaffolding systems hold up the bridge during construction until it can support its own weight. But with a 565-meter drop to the canyon floor and absolutely no access to that canyon floor, falsework was completely impossible. There was nothing to build falsework on, just empty air and a very long fall. The solution was a technique called cantilever construction, and at this scale, it had never been attempted before. Each side of the bridge would be built outward from the towers, extending into empty space like 2 arms reaching toward each other across the void. The bridge would literally build itself over nothingness, 1 section at a time, balanced entirely by engineering precision. Cable-stayed bridges use massive steel cables running from the towers to support the roadway deck. As each new section of the deck was added, extending further into the canyon, new cables were attached to hold it in place. The structure balanced like a seesaw, with the tower as the fulcrum and equal weights extending in both directions. The cables weren't just support. They were counterweights, holding the growing arms of the bridge in perfect equilibrium. The precision required was extraordinary. Wind speeds at this altitude could change rapidly and unpredictably. Any asymmetry in the construction, any difference in weight between the 2 extending arms, could cause dangerous swaying. Or even catastrophic structural failure. Engineers monitored every movement with GPS sensors accurate to the millimeter. They tracked the temperature of the steel because even small thermal expansion could affect the alignment. Remember those engineers who said this was impossible? They weren't wrong about the challenges. They were wrong about what human determination could overcome. The main span stretches 720 meters across the canyon, a distance that seems almost reasonable on paper, but becomes terrifying when you realize there's nothing but air beneath it. Each section of the deck had to be lifted from the canyon rim using specialized cranes and positioned exactly in place before being secured with bolts and welds. The tolerances were measured in millimeters, while the heights were measured in hundreds of meters. Special cranes mounted on the already completed sections of the deck reached forward into the void to grab the next prefabricated piece. These cranes essentially crawled forward as the bridge extended, always moving on to the newest section to grab the next one. Workers operated these machines while suspended hundreds of meters above the canyon floor, watching the earth so far below that individual trees looked like blades of grass. Safety harnesses were mandatory for every worker, but at those heights, even a minor accident could be fatal. A dropped tool could kill someone on a lower level. A loose bolt could unbalance a crane. The construction team implemented some of the strictest safety protocols in Chinese infrastructure history. Morning briefings reviewed weather conditions, equipment status, and emergency procedures. Workers who showed any signs of fatigue or distraction were immediately reassigned to ground-level tasks. Despite these precautions, the psychological toll was immense. Some workers developed fear of heights during the construction, even those who had never experienced it before. Others grew strangely comfortable with the void beneath them, eating lunch with their legs dangling over 500-meter drops. The human mind adapts in strange ways when confronted with the impossible-made routine. The two sides of the bridge grew toward each other for 3 years. Centimeter by centimeter, meter by meter, the gap slowly closed. Workers on one side could eventually see their counterparts on the other, could wave to them across the shrinking distance. What had once seemed like an unbridgeable chasm was becoming a connection. Finally, in September 2016, the moment of truth arrived. The gap between the two cantilevered sections had shrunk to just a few meters. Closing this gap is one of the most critical and nerve-wracking operations in bridge construction. Temperature changes cause steel and concrete to expand and contract throughout the day. A section that fits perfectly in the cool of night might be millimeters too long in the afternoon sun. Engineers chose a specific time window in the early morning hours when temperatures would be stable enough to make the final connection. They had watched weather patterns for weeks, waiting for the perfect conditions. The cranes lowered the final deck sections into place with agonizing slowness. Workers communicated via radio, calling out millimeter adjustments. The entire construction team held their breath. And then, with a precision that seemed almost impossible given the scale of the project, the two halves met with less than 2 centimeters of misalignment. Workers installed the final deck sections, welded the final connections, and for the first time in history, it was possible to walk from one side of the Beipanjiang River Canyon to the other in minutes instead of hours. Remember that village with the hospital on the other side? That day-long journey became a 5-minute drive. The completed Beipanjiang Bridge stretches 1,341 meters in total length. The two main towers rise 269 meters above the deck, reaching toward the sky like concrete sentinels standing guard over the canyon. The bridge contains 23,000 tons of steel, enough to build 3 Eiffel Towers. Over 120,000 cubic meters of concrete were poured, enough to build a sidewalk from Beijing to Shanghai. But the most impressive number remains that height, 565 meters. To put it in perspective that your mind can actually grasp, if you dropped a stone from the bridge deck, it would fall for nearly 11 seconds before hitting the water below. 11 seconds of free fall. Most people can't hold their breath that long. The bridge opened to traffic on December 29, 2016, almost exactly 4 years after construction began. A journey that once took hours now takes less than a minute at highway speeds. Drivers cross without even realizing they're experiencing something that engineers once called impossible. The economic impact was immediate and transformative. Villages that had been isolated for generations were suddenly connected to markets, hospitals, and schools. Local farmers could transport their products to distant cities for the first time, selling directly to buyers instead of to middlemen who controlled the only access routes. Tourism increased dramatically as visitors came to see both the engineering marvel and the stunning natural scenery it revealed. Property values in previously inaccessible areas increased by over 300% within 2 years. New businesses opened. Young people who had left for cities because there was no opportunity in their home villages began returning. The bridge didn't just cross a canyon, it crossed generations of isolation. But the Beipanjiang Bridge is more than a single transportation project. It's a symbol of what's been happening across China's western provinces for the past 2 decades. Since the year 2000, China has built more high bridges than the rest of the world combined. That's not an exaggeration. Of the world's 100 highest bridges, over 80 are in China. Many of them are in Guizhou, the mountain province that was once considered permanently impossible to develop. The province that cartographers once marked as essentially empty is now crisscrossed with highways and railways that float between peaks like threads of a spider's web. The Beipanjiang Bridge held the record for the world's highest bridge for several years after its completion. It has since been surpassed by another Chinese bridge, the Beipanjiang Railway Bridge, which carries high-speed rail across the same river further upstream. China broke its own record, and they're likely to break it again. The techniques developed for these extreme bridges are now being applied to projects around the world. Engineers from the Beipanjiang project have consulted on high-altitude bridges in Nepal, Bolivia, and other mountainous regions where terrain once seemed to make development impossible. The lessons learned over this canyon are helping connect isolated communities across multiple continents. The construction employed over 1,000 workers at its peak, with specialists rotating through based on which phase of the project required their expertise. The total cost was approximately 1 billion yuan, roughly $150 million at the time. For a project of this unprecedented complexity and scale, engineers around the world considered that remarkably cost-effective. Similar projects in other countries have cost 10 times as much for lower bridges over easier terrain. Some critics have questioned whether such ambitious projects are truly necessary. Could the same connectivity be achieved with tunnels or more conventional routes? Perhaps. But there's something profound, something that touches the human spirit in a way that statistics cannot capture, about watching a car cross a space that was impassable for all of human history, about seeing a highway floating through clouds, about knowing that the impossible has been made routine. The mountains of Guizhou haven't changed. They're still steep, still rugged, still formidable. The Beipan River still carves its canyon 565 meters below where traffic now flows. Nature hasn't been conquered, but it has been crossed. Every day, thousands of vehicles traverse the Beipanjiang Bridge, trucks carrying goods to market, families visiting relatives, ambulances rushing patients to hospitals that once seemed as distant as the moon. Most drivers probably don't think about the engineering that makes their journey possible. They're focused on their destinations, their families, their ordinary lives made possible by extraordinary achievement. But if you ever find yourself driving across southwestern China and your GPS tells you to take the expressway over the Beipan River Canyon, look out the window. Look at the mountains that engineers once said couldn't be crossed. Look at the empty space beneath your wheels. And remember that you're traveling 565 meters above a river on a bridge that was once declared impossible, following a path that didn't exist just a decade ago. They said it couldn't be done. The canyon was too deep. The walls were too steep. The challenge was too great. But somewhere right now, a driver is crossing that same canyon in less than a minute, probably checking their phone, completely unaware. They're experiencing one of the greatest engineering achievements in human history. That's the real story of the Beipanjiang Bridge. It's not just about concrete and steel and cables and calculations. It's about refusing to accept that something cannot be done. It's about looking at an obstacle and seeing a challenge instead of a barrier. It's about the human drive to connect, to build, to overcome. The next time someone tells you something is impossible, remember this bridge. Remember the engineers who looked at a 565-meter canyon and said yes. Remember the workers who operated cranes half a kilometer above solid ground. Remember the explosions that split mountains and the precision that joined two halves of a bridge with centimeters of accuracy. Impossible is just a word. Beipanjiang is a bridge. What impossible project should we cover next? Drop your suggestions in the comments and the most requested one becomes our next video.